Welcome to Physics Concepts Lecture 28. Today, we will explore the fascinating phenomena of reflection and refraction. These concepts are fundamental to understanding how light interacts with different surfaces and mediums. Reflection occurs when light rays bounce back from a surface. This is a common experience in our daily lives, such as when we look into a mirror and see our reflection. The law of reflection states that the angle at which light hits a surface, known as the angle of incidence, is equal to the angle at which it reflects off the surface. This principle is crucial in understanding how mirrors and other reflective surfaces work. Diffuse reflection happens when light rays reflect in multiple directions due to the irregularities of the surface. This type of reflection is common with rough surfaces, causing light to scatter in various directions. Refraction is the bending of light as it passes from one transparent medium to another, such as from air to water. This bending occurs because light travels at different speeds in different mediums. According to Fermat's principle of least time, light will always take the path that requires the least amount of time to travel from one point to another. This principle helps explain the behavior of light during refraction. When light passes through materials like glass, its speed changes, causing it to bend. This change in speed is described by the refractive index, which varies for different materials. Dispersion occurs when white light is separated into its component colors, such as when light passes through a prism. This phenomenon is responsible for the beautiful spectrum of colors we see in a rainbow. A double reflection within a raindrop can produce a secondary rainbow, which is fainter and has reversed colors compared to the primary rainbow. This occurs due to the complex interactions of light within the drop. Total internal reflection happens when light traveling within a denser medium hits the boundary at an angle greater than the critical angle, causing it to reflect entirely within the medium. This principle is used in fiber optics. The critical angle is the minimum angle at which light must hit the boundary between two mediums to be totally reflected. Beyond this angle, light does not pass through but is entirely reflected back. A converging lens is thicker in the middle than at the edges, causing parallel light rays to focus at a point. This type of lens is used in devices like magnifying glasses and cameras to focus light. A diverging lens is thinner in the middle than at the edges, causing parallel light rays to spread out. This type of lens is used in applications like eyeglasses for correcting nearsightedness. A real image is formed by light rays that converge at a point and can be displayed on a screen. Unlike virtual images, real images can be projected and viewed directly. A virtual image is formed by light rays that appear to diverge from a point behind the lens or mirror. These images cannot be displayed on a screen but can be seen when looking through the lens or mirror. Let's summarize the key terms we've covered: reflection, refraction, Fermat's principle of least time, law of reflection, diffuse reflection, critical angle, total internal reflection, converging lens, diverging lens, real image, virtual image, and aberration. Thank you for watching. Please like, share, and subscribe to this channel. Add a comment below the video to share what you learned and suggest topics for future videos. This presentation contains copyrighted material used under the Fair Use Doctrine for educational purposes. Links to relevant resources are provided in the video description.